Okay, everybody, today we're going to be continuing what we learned yesterday, but this time is going to be a little bit more advanced, and we're going to actually take some notes with vocabulary terms. First, let's start off with this word monomial. That's a word that I didn't understand whenever I first heard it, so if you don't understand this definition, that's okay, but write it down anyway. A monomial is a variable or a product of a number and one or more variables. So a monomial is something, write down the definition and then copy this example. It could be x, it could be 2x, it could be 15, or it could be 15x cubed. Or it could be 21 A, B, C, or 21 x, y, z. So a monomial is just any number or variable or number times a variable or more than one variable. As long as it's just one thing altogether, that's a monomial. Now let's look at this first example. It wants us to separate 5x to the fourth power and name each individual part of that. What's that 5 doing to 5x to the fourth? It's multiplying it, so that is the coefficient. Bringing it back to a word we learned in like the second week of school. X. X, that has to do with what we just talked about. X is being raised to the fourth power, and yesterday in your notes it said that if it is being raised to the power, that is the base. 4 is the actual exponent. X to the fourth is x raised to the fourth power. Make sure you wrote all that down. It wants you to use a calculator to evaluate each of these. So I will let you go ahead and do that. I will not put those answers there, but you do need to find out using a calculator what these 4 answers are equal to. If you're on your keyboard for your computer, then you would put these exponents in here as 2. Then you put the up arrow, which is Shift 6. That's actually called the caret key. 2, caret key, 2 times 2, caret key, 4. If you put that in your keyboard onto like the Desmos calculator, or even in Google calculator, this should work. And if it didn't work like that, then you would put it, well, let's just see what this is going to be. It's going to be 2 to the 6, and 2 to the 6 is going to be 64. So the answer you should be getting is 64 for that. The pattern that you should see is that you always get 64, which means 2 to the 6 power is always 64. And 2 to the 6 can be written many ways using its factors. Rewrite each of these in expanded form using the properties of multiplication. I'm going to do 3 of these with you. The rest you will do. So let's just start off with the first one. M to the fourth power means we have m times m times m times m times m to the fifth power, which is m 5 times. So I should have 1, 2, 3, 4, 1, 2, 3, 4, 5. Then write it as a product of a monomial in simplest form. Then write it as a product of a monomial in its simplest forms. That means after you expand it, then simplify it like we did yesterday. That is 1, 2, 3, 4, 5, 6, 7, 8, 9 m's that are all multiplying together. So that's m to the 9th power. The next two are done the exact same way. The fourth one, though, is slightly different, so I will do the fourth one with you. We have p cubed, so that's p times p times p, q squared, so that's q, p cubed, q squared, times p squared, q to the 4th. Okay, so the best way to write this is to regroup the letters. So we have 3 p's in the first term. Those are all multiplying. Then you have 2 p's from the second term. Then you have 2 q's from the first. And then 4 q's from the second one. You can rewrite this because it is all multiplying together. And when you're multiplying, you can do it in any order that you want. So let's do all the p's first. That's 1, 2, 3, 4, 5 different p's. Well, they're actually 5 of the same p's, and those are all multiplying. So that's p to the 5th power. And that is multiplying how many q's? Another 5. So that's p to the 5th times q to the 5th. While editing, I was able to recount those q's, and I see that it's actually 6 q's. Pause the video here so that way you can answer the questions that I am not doing as an example. The next two are the same. Just remember to separate the things that are multiplying. Separate the little individual pieces. Just separate each little thing that's multiplying and then regroup them together. All right, so in this last one, I'll write it, but it'll be up to you to get the final answer. We have 8 times r to the 5th power times s times q times q times q, because it's q cubed, times r times s times s times s times s times s times 9 times q times s times s times s. Okay, so it looks like there's a lot to do, but really we're going to combine the numbers that match, the numbers that are alike. So the 8 and the 9 are the regular numbers. So the first thing you're going to do is you're going to multiply 8 times 9 to get 64. Nope, 72. Then count how many r's there are. Or since q comes before r, alphabetically, let's count the q's. We have 1, 2, 3, 4 q's. So we're going to put q first because that's the alphabetically that comes before the other letters here. And we had 1, 2, 3, 4 q's. So that's q to the 4th power that we have multiplying. QRS. So r is next. How many r's do we have? We have 1, 2, 3, 4, 5, 6. So we have r to the 6th power. Finally, our s's. We have 1s. Oh, I forgot to scratch through my r's so that way you know that we already did those. 1, 2, 3, 4, 5, 6, 7, 8, 9. S to the 9th power. So we have 72, q to the 4th power, r to the 6th power, s to the 9th power. There was a shorter way to do that, and that would have been to be using the full. And I'll show you the shorter way to do that coming up. Make a conjecture. That means come up with your own conclusion, with your own thoughts, summarize how we multiplied the above things. So in just a sentence or two, explain what we did to multiply these numbers, and then write that down in your notes. So that's what you're going to write for part E. Also make sure that you multiply the other numbers that we didn't do as an example up above. To do. Okay, now that you've made your own little summary, this next part should be a little bit easier. They want you to multiply these numbers, but they want you to do it without using the expanded form. So hopefully what you noticed up here was you look at the terms that are the same base. So if we looked at all of the R's, and we looked at all of the Q's, and we looked at all of the S's, and then we added plus 1, plus 1, plus 1, because that's what it's like. We counted 1, 2, 3, 4, 5 R's. So we just counted each R, and that raised the exponent by 1. But here we can see that the exponent for the first W is 8, and the exponent for the second W is 10. So this is the same thing as W to the 8th plus 10th to get W to the 18th power. I'm only going to do one more with you, and that's going to be the last one. You need to be able to do all of these, but I'll show you this last one. We have 3, and we have 1/3. Those are the regular numbers. 3 times 1/3 just makes the number 1, so we don't even need to write that. These two are going to balance out. Then we have m to the 4th power and m to the 1st power. So m to the 4th plus m to the 1st makes m to the 4 plus 1. Then we have our n's. N to the 1st is this first one. And then n to the 5th, so we're going to add 5. Then we're going to multiply by p squared plus 4. The first one has 2 p's. The second term has 4 p's. So we're going to add those together. Let's add these exponents now to get m to the 5th, n to the 6th, p to the 6th power. And this is the final answer.